So now that we've covered how to create tables with full text indexes, let's discuss how we might use them in our queries to search. The primary function used with full text indexes is the match function. Match can be used with select, update, and delete queries, and as you can see in the syntax example below, we are using a select query and filtering with a where operator using the match function. Simply provide the name of the column you indexed when you created the table and provide a string for an expression to search. Looking at the example table of articles from before, we assign the full text index to the body column. So when we use the match function, we supply the body column as the first argument with the search term of SingleStore. So here in Studio, I've created a pipeline into our journals table from an S3 bucket containing medical journals. Now, running the count all statement you see here, we can see that our table currently holds 31,000 journal entries. So if we wanted to see which journals had mentions of, let's say, the word optometry, we can write a query that matches the body against the search term optometry, and we see that we get 40 rows returned. Now we can change that search term to dentistry and we can see 79 rows are returned. And with neuropathy, we see 115 rows returned. And also, if we include the match function in our select statement like this, what we see outputted is actually the relevancy score of how well the document matched our search term. So if we give this column an easier alias of score and order by the score descending, we can see which documents were most relevant to our search term. The highlight function is similar to the match function, but instead of just simply returning the entire document where the search term was found, the primary purpose of highlight is to actually return a small snippet of text where the search term was found. SingleStore will package these snippets in a JSON object that is essentially an array with elements for each occurrence in the document. So if there were 5 occurrences of the search term in a single document, there would be 5 fragments in the array. Each fragment contains 3 values: the offset or position of this fragment in the document, the unique term count, and the actual snippet of text. So let's look at an example. Here is the query from before where we search for articles containing the keyword SingleStore in the body. Instead of selecting all, we can replace the star with a highlight statement, so we are now selecting the JSON blobs the highlight function returns. Now, this is just one JSON object, essentially one row or document where the search term was found. However, we can see that this particular document had 2 occurrences of the search term SingleStore in the body, one at offset 97 and one at offset 408. And the offset is simply the literal character position of the first character in the fragment. So the first character A is the 97th character in the document, and the character I is the 408th character in the document.